Okay, next up, Job Snijders. Are you here? There he is. Okay, we've got Job speaking about PeeringDB accuracy.
Where's the remotes? Yep, just the green button right there. Hi. I want to talk a little bit about how accurate the data is in PeeringDB and what that might mean for you as a network operator when automating the hell out of your network. I'm Job Snijders. I work for Atrado. Atrado does a lot of peering, and it is in this slide that I became inspired to do some research in this area. I also recently joined the PeeringDB admin team, and I do stuff with routing. Originally, PeeringDB was conceived by the Illuminati to crack down on big transit and give the little man a chance of finding each other and set up peering. This eventually evolved into a website based on PHP, and on that website, a third of what you could call critical ASNs has registered some kind of information regarding their network. Now, critical ASN is a very loose definition. PeeringDB, in my opinion, was a real game changer because it made life so much easier than scraping CSV files or parsing HTML to find out what the other guy's IP addresses are. PeeringDB is run by volunteers. There are some people in the admin team that are truly dedicated, and they spend hours per day munching through tickets and helping users to get this running. The data itself, similar to Wikipedia, is 100% user submitted. There is no import from other databases like URIX or internet exchanges themselves. This is all user-submitted data. An example PeeringDB record might look like this. In the upper right corner, you'll see a listing of internet exchanges, and next to it IP addresses, and then bandwidth information. You can lie all you want. Nobody will check this information. And in the left side, you'll see various nuggets of information like which IRR record could be used, or the company name, or phone numbers, anything you want. It's your record, and you can fill it. PeeringDB offers various interfaces for automation. You can talk SQL against the PeeringDB server. I don't really recommend using this because it tends to be a little bit slow. Also, every night around 1 or 2 a.m. standard time, a dump of the SQL database is published on an HTTP URL, and you can import that on your own SQL server and hammer the hell out of that. And then, of course, there is the web interface, which I showed in the previous slides. In the future, we hope to offer RESTful APIs with kinky keywords such as JSON or maybe even XML. But that's the future. We don't have that today. Now, what we're going to discuss is the big question: how useful is the user-submitted data in PeeringDB? Can I actually just import the data and really run my tools against this and use it to semi-automatically turn up BGP sessions? To address this problem, we figured there are 2 useful data sources out there. One is the data source or data set that we want to validate, PeeringDB, the SQL dump. And the other one that is very useful is actual show BGP summary outputs from real networks. We'll throw this all together in one giant cocktail and then go over the results. To collect those show BGP summaries, I created a small website, research.peeringdb.com, and last week I emailed that around to people like, visit this website, submit your data, and help out assessing the accuracy. On the website, there was a big input field where you could just copy-paste from your Cisco, Brocade, iOS XR, and Juniper and a gigantic, monstrous regular expression would go over that input and figure out what the peering sessions look like. So from this example, you'll see quite some established sessions, and those are of interest, and there's also one or two shut down sessions, and we throw those away because they mean nothing in this research. You press submit, and the website would give you feedback, is this what you want to submit? And the website would try and figure out which sessions are actually on IXPs and which are not, and discard everything that is not relevant. So information such as how many prefixes you send or how many you receive, it doesn't matter. The only thing that mattered was the remote IP and the remote ASN. And by submitting data on this website, you would confirm that you have seen an established session with this IP and ASN. Quite some networks contributed data to this small work. Amongst them, quite some big networks, also a lot of small networks. It came from all over the place. In total, 33,500 BGP sessions were submitted through this tool, and in my opinion, that was quite a good number. It was spread over 256 individual submissions, and this ran for like 7 days, so not too shabby. So data source 1, our PeeringDB data set that we want to verify. Today, in PeeringDB, there are roughly 4,700 networks registered, and that represents about 10% of the default-free zone. In those records, there are connections are described. At the bottom, you see such an example. It is our listing of DKIX Frankfurt. And what we do is we list our IPv4 address in a record, and in a separate record, we list our IPv6 address. There are about 15,000 of such records in the PeeringDB database. The IP address field in the current PeeringDB implementation is a varchar 128. It has to be unique, but you can, in essence, put anything you want there. And I've noticed that quite some people use this freedom to describe imparsable garbage. I especially like the second IP in this list because I think the guy was trying to combine the best of IPv4 and IPv6 and stick that in one string. But this, a lot of this is comments, which is okay. I mean, if you're leaving an exchange or going to an exchange at some point, that could be useful for people to know. But there is quite some just you can throw that away. After, say, 15,000 entries in PeeringDB, about 10% is not parsable if you don't do a little bit of scrubbing. And with some very light scrubbing, here's a small Python example, it's like 2 lines, you already recover like 60% of that unparsable IP entries. In this case, the scrubber strips leading and trailing white spaces. It removes everything after a slash, and the remaining part it tries to parse as an IP address object in Python, and if that works, cool, it must be an IP address. If it doesn't work, it's useless data. If we use this small scrubber and look at what's in the records, 69.5% of the user-submitted data in PeeringDB is parsable. They are valid IPv4 and IPv6 addresses. And to be honest, I thought this number would be much, much lower, but only 680 entries are useless, and we can probably hunt down those users and ask them to rectify this and make something more useful. Now, the second data source is what I call ground truth, the actual sightings that networks report regarding established BGP sessions that they have seen in the wild. As I mentioned earlier, 33,000 sightings were published, 28% of those were IPv6 sessions, and 72% were IPv4 sessions. The 33,000 sightings were about 11,000 unique combinations of IP and ASN. So that means that for a lot of records, we, in essence, on average, got about 3 confirmations whether it was up and correct or not. Out of those 11,000, I matched it again against the PeeringDB database. IXP operators can describe which prefix is their peering length prefix. So I matched all the sessions against that list of prefixes, and roughly 9,000 unique tuples remained that we could identify as something that was known in the PeeringDB database. 67,000 BGP sightings could immediately be confirmed with the PeeringDB entries. This meant that from all data that was submitted, 75% of it had some corresponding entries in the PeeringDB database. Another take on that number is that we validated 44% of the entire data set in PeeringDB. So in my opinion, but I'm not a scientist, this represents a good portion of the data there. So we don't need to do very complicated extrapolations. Only 64 IP addresses resulted in what I call a conflict, where what was seen in the wild deviated from what was registered in PeeringDB. I'll zoom in on those 64 IP addresses. 57 of those were IPv4 sessions, and I went through all 64 of them to try and figure out why what was seen in the wild did not match the PeeringDB database. And I concluded that 60% of those entries that were in conflict were actually IP addresses registered by some company in the PeeringDB database. The company left an internet exchange, and the internet exchange then recycled the IP address and gave it to a new party. And you could kind of figure this out by looking at the dates of when the last update was done to a PeeringDB record, or look at which AS number was higher or lower. So old still data is something we as admins need to figure out how we can pursue people to update it. 26% of these conflicting sightings were actually networks that have merged or were migrating from one AS to another, and they do what I think is the local AS trick to old peering sessions, where maybe they cannot reach the other peer, but they want to keep peering, so they'll just give up and use local AS to keep that session up and running. 14% was just typos, where people would just flip 2 digits in the AS number, or something that really looks like, oh, I fat-fingered this, oops. And about 8%, I just had no clue why what I saw in the show BGP summary data was deviating from PeeringDB. The 60% still data, most of those entries were actually the Moscow Internet Exchange. That really stood out. I don't know why, but that was it. So let's look at what this means. 75% overlap between the PeeringDB data and the sightings in the wild. 44% of PeeringDB has now been verified as correct. This means that 99% of the data in PeeringDB is actually correct. And that flabbergasted me, because I thought it would be 75%. So that's why I included the next slide. 99%, guys, it's awesome. This means we can really use PeeringDB, and everybody should use it. The fault margin, in essence, is about 1%. So if 1 out of every 100 peering sessions that you set up go wrong, that's a very good score. It will lower the burden on your NOC service desk. Keep in mind that scrubbing the data that you get from PeeringDB is worth the effort. You'll easily yield a few hundred extra IP addresses from PeeringDB. And if we would optimize the scrubber a little bit, we could even make it into something where we salvage 75 or 80% of IP addresses that have been mistyped in a way. Well, as admins, we'll talk about whether it is acceptable to force a little bit of scrubbing on this. Should it be wild text or not, or should we make a separate comment field and a separate IP field, which can never be anything else than an IP address? We'll figure that out at some point. How can you keep improving the data in PeeringDB? How can you ensure that we'll keep the number high as it is? I recommend that in the current PeeringDB setup, you use one IP address per entry. I've seen quite some people that try to fit both an IPv4 and an IPv6 address on the same line because they feel it's cheating to list the entry twice and then double listing the bandwidth as well for v6 and v4. I don't care about bandwidth at all. If I want to peer with you, I want accurate information. That's the only thing that matters to me. So to accomplish this, I really urge you guys, one IP address per field. Don't enter comments, don't add subnet masks, only IP addresses. In terms of automation and the still data number that we saw, an option could be that in the future of PeeringDB, you will add some freshness factor, where if you request through this beautiful JSON API that will really arrive someday in the future, we're not committing anything here, where you could say, like, give me the most, all entries that were updated most recently. And this will be a nice feature because you can have the old records from networks that left internet exchanges. You don't have to touch their data, but you allow newcomers that got that recycled IP address and they updated more recently, so it's probably more accurate. We could do stuff like that. Maybe it's worthwhile maintaining this feedback loop where, say, once every half year, we ask networks, like, submit your show BGP summaries so we can verify the current state of PeeringDB. We could make a periodical thing out of this if the community would appreciate that. And keep scrubbing data that you pull from PeeringDB. Really do some sanitizing on what you expect, and then a lot of it is workable, like 99%. This concludes my short presentation on PeeringDB's accuracy, and I was wondering, are there questions that you would like answered?
Hello, I'm Patrick from, let's call it the PeeringDB today. So we looked at your data and we actually talked about this. Sorry, everybody else, that we're talking about something we discussed, but I think it's important to the group. We talked about this, and you, for instance, noticed that Akamai had some data that mismatched because we were local ASing some peers due to legacy stuff. Where does that fit into your data, and did you look at how many people were doing something like that, and did that make it even higher, or does it matter because the 99% kind of washed over that anyway?
Well, so for instance, the Akamai entries were in the 64 conflicted IP addresses. So the 99% is everything that really, where the real world correlates with what PeeringDB states. In your particular case, I think a nice feature in PeeringDB would be that you could list maybe legacy ASNs for an entry, and you could say, well, our preferred AS for this IP address is our new AS or the big AS, but you might still have sessions somehow with this, and this AS. But these are actually corner cases given the low numbers.
Okay, thank you.
All right, anybody else?
Hi, Mehmet from ICANN. You mentioned that when you're typing the IP addresses, not to use columns or anything like that in the stats. I think it would be useful PeeringDB to allow those who are just want to let others know that they are in the exchange point, but they don't necessarily want to display an IP address there. I think there should be somewhat like an option there where that is possible. Right now, I know that some people are using columns, like me, because that's basically my policy. I just peer with the route servers, but it would be good to have that option. So I am in the exchange point, but I don't necessarily want to show my IP address.
I agree. One of the strong things about PeeringDB is actually the fact that you can put in whatever data you want. And originally I was like, no, it all must be strict and we must force people to enter IP addresses, otherwise my script doesn't work. But others pointed out, well, this may be your view, but other people like you just want to list that they're present and not necessarily disclose more information than they deem needed. So in a new PeeringDB iteration, I think it would be good to make all kinds of data optional, but that you could classify what the information means. So instead of having a mixed IP/comment/empty field, you could have something like, don't publish my IP address, or this is a comment regarding the connection. So it would be easier for parsers to figure out what the data means, yet keeping that freedom of what you want to enter into PeeringDB.
Kevin Bloomberg, The Wire. You mentioned much of the cruft was stale data, as in the recycling of IXP, IPs, etc. The people that have the stale data are in many cases not in this room. Is there a way to really push getting the feedback to them on some of the simpler stuff, automate it, and in some cases just doing a cleanup day once every 2 or 3 years to try to get the people who aren't in the room getting their data updated?
Hi, I'm going to take that. We're working on ensuring that the data from the IXs is correlated correctly. The issue is, as Job was saying earlier, it's all user-entered data, so we don't want to just display data. We don't want, for instance, an IX to say, the wire has this IP address without your say-so. But we also want to be able to say, if you put in an IP address, that the IX confirms that's your IP address, and if it changes a way for the IX to notify PeeringDB, it's not your IP address, et cetera, et cetera, et cetera. So that's all being worked on. We actually have a meeting tonight at 6 to deal with it. So it'll be more than scrubbed every 3 years. Hopefully it'll be scrubbed in real time.
Right. Thank you.
Another option in this space that we have is to try and reach out to the listed email addresses and the email address that we have internally and see if the email bounce. If the emails bounce and they keep bouncing, then after 3 months we might maybe conclude that the company doesn't exist anymore, and we'll maybe flag it as inactive. Or we should reach out and start nagging users that we feel have incorrect data in PeeringDB and try and convince them to change it instead of us forcing it upon them.
Okay, anybody else? Going once, going twice? Okay, Job, thank you very much.
Thank you for your time.